dear student, in the last class, I have just introduced about the fifth type of preparation from alkenes. So this plays a very major role, right? So why? Because here Marconic and anti-Marconic comes in existence, right? So Marconic of rule. Yesterday I said for the Marconic of rule we require unsymmetrical alkene. Very important. So in an unsymmetrical alkene, the negative part of the reagent will go and attach it to the double bonded carbon who is having less number of hydrogen. See. So there will be an unsymmetrical alkene. I will write it here. CH double bond CH2. Say for example, if we took a HBr, right? So in Marconic of rule, we see HBr as a reagent. See, now the definition. According to Marconikov's rule, in an unsymmetrical alkene, this is an unsymmetrical alkene, that is 1-propene. In an unsymmetrical alkene, the negative part of the reagent, this is the reagent and whose negative part is Br. The negative part of the reagent will go and attach to the double bonded carbon, right? Negative part of the reagent will go and attach to the negative part of the reagent will go and attach to the double bonded carbon atom who is having less hydrogen, not single bonded carbon, right? So among the double bonded carbon, among these two, who is having less number of hydrogen? This carbon. So thus the negative part, according to Marconic, the negative part will go and attach to this carbon, right? So that is nothing but the Marconikov's rule. Understood? So now see here an example from alkene. So yesterday only I said, so based on Marconikov's rule and anti-Marconikov's rule, you will be having definitely two questions in NEET as well as AEE as well as your normal CET, right? So now, so the negative part will go and attack. So here, see, there are two major products. Two products. Formation of two products will take place. So say this as a first product and this as a second product. So now there will be two possibilities according to Marconic. According to Marconic of rule, I can say CH3 CHX, the bond shift takes place and CH2 becomes CH3. This is according to the Marconic is major product. It will be always 80%. That means the product will be. And one more possibility is CH3. Now there is a possibility to go and attack this X as on this carbon. So now in that case CH, now if the X is attacking on this carbon, then this will move here and become CH2. Double bond is converted into single bond CH2 again X, right? And it is a minor product and whose percentage is 20, right? So this is nothing but preparation of haloalkane from alkenes, right? So according to Marconic, so I am just going in depth, right? So for reaction, you just show these two products, one as major with this less number of carbon atom and this has a more number of carbon. According to Marconics, we are going, right? So why I am explaining is nothing but, so this part is very important for your competitive examination. So now, again, what is the difference between Marconic and anti-Marconic of rule is nothing but, in anti-Marconic of rule, right, this will become 80%. Dear student, listen carefully. In anti-Marconic of rule, the same thing we use, no change. Then how to identify Marconic and anti-Marconic of product is nothing but, in case of see, I'm talking about anti-Marconic of rule, right? So now in anti-Marconic of rule, this becomes 80% and this becomes 20%. Anti means opposite. of what? Marconi. But we use unsymmetrical key, the negative part, same to same. That means negative part. Now the major product will be the negative part of the reagent will go and attach to the double bonded carbon atom having more number of hydrogen. So that means this will be just a change here. So then how to identify which one is, why? Because directly in need high level they will give directly this as a major and this as a minor. Then how to identify? For the identification of anti-Markovnikov rule, you just check if they have used a hydrogen peroxide as a reagent, right? Hydrogen peroxide. They will give on this arrow. That means like this H2 in the presence of H2O2. In the presence of H2O2 means you just say that as a anti-Markovnikov rule. Understood? Both the rules are same. The minor change is there. That means in the product, right? If the Markovnikov product in the Markovnikov this product is major means in the anti-Markovnik it becomes minor. In the anti-Markovnik, if it is major product means in the Markovnik it becomes minor, right? So you just try to understand on these bases, right? And which are very important. And the next, sixth preparation is on Finkelstein reaction. Very important. The named reaction in organic chemistry are very important. They might ask you any questions. Or by halogen exchange method, this reaction is also called Finkel. Sixth reaction, Finkelstein reaction, or else this reaction is also called by halogen exchange method. By halogen exchange method. So that means here one halogen replaces other halogen. That is the case. But how in our theory examination, Finkelstein reaction in 1 mark part, Finkelstein reaction has been asked for several times. One mark reaction. That means they will give a complete reaction and they ask you to name that reaction, right? Halogen exchange reaction. In this reaction, what we will do is allyl chloride or alkyl bromide when heated with solution of sodium iodide in dry acetone gives corresponding alkyl iodide. This reaction is called as what? What? Finkelstein reaction. So that means first of all alkyl chloride or else bromide one we can use reacts with sodium iodide in the presence of dry acetone, right? What happens is, see, simply this iodide will replace, see, why we are saying this as a halogen exchange means this is also a halogen, iodine is also a halogen. One halogen is replacing other halogen, right? So that's why by halogen exchange method. So that means it becomes Ri plus NaCl, right? Simply you just replace Cl with I. That's why it is called exchange method. That means halogen to halogen exchange method one we can say, right? So if I write it in the example form, then it becomes CH3Cl plus NaI gives same in the presence of CH3I methyl iodide plus sodium chloride. So I have just introduced in place of our alkyl as a methyl, right? So this is a Finkelstein reaction, and one more halogen exchange method is there, that is called Schwarz reaction. So that's why these two are very confusing. So now you just say this as a Finkelstein. So here only I will write one more halogen exchange method, that is seventh method of preparation of haloalkane. So that is nothing but Schwarz reaction. Seventh method, Schwarz reaction. So these reactions are very important, dear students, right? So Schwarz reaction. So here in the Schwarz reaction, it is also a halogen exchange method, but here instead of NaI for Schwarz reaction, you just don't get confused. Same RCl we will use. In place of NaI, we are using what? Silver fluoride, right? AgF. So this is the difference, dear students. So that's why Finkelstein as well as Schwarz reaction they will ask randomly in the examination. Why? Because these two are same reactions. That means halogen exchange methods only, but they differ in their using of reagent. Uses of reagent that will be different. So here again the same thing will happen. So you just in place of Cl you introduce F, and in place of F you introduce Cl. So these are the just the same. That means alkyl halide reacts with silver fluoride to form a haloalkane is nothing but what? Schwarz reaction. And the different is in case of Schwarz as well as the Finkelstein is nothing but in case of Finkelstein we are using a sodium iodide as a reagent, but in case of Schwarz reaction we are using a silver fluoride as a reagent. So this is the most important point. Why? Because for 1 marks they will ask randomly, right? So you remember these very important points, right? So now we will see some physical properties of haloalkanes. So till now in our chapter we saw the basic nature, how they behave, what is the nature of bond of haloalkane, and how to prepare these haloalkanes. After seeing all these things, what are the properties? I mean, physical, that may be physical or that may be a chemical property. We will see one by one. The first part is the physical property, and based on physical property also, we will be having so many questions in your NEET as well as the CET examination. So don't neglect these points. These are very easy, but they have some twist nature, right? So the first point, haloalkanes are having higher boiling point. So first point is haloalkanes. Haloalkanes are having higher boiling points. Higher boiling points. So what does it mean? So boiling point increases as the number of halogen increases, right? Number of halogens. So that means, see here, I will show as an example, CH3Cl, CH2Cl2, CHCl3, CCl4. So the question will be like this. So that's why we will get confused. So how to identify you? That means first of all, that means haloalkanes are having higher boiling point, right? So they have high boiling point, no doubt, because of all over single bond is there. Only sigma bond for breaking of sigma bond. What we require? We require more amount of energy, right? So that means if the number of that means they will ask the question not directly, they will ask by giving like this. So that means remember one point during your NEET as well as the CET case, whenever the number of halogens increases, the boiling point always goes on increases, right? Compared to the parent alkanes. So that means, say for example, apart from this, right? So that means among these, this will be having more boiling point than this. This will be having more boiling point than this, or this will be having more boiling point than this, right? So comparatively, so haloalkanes are having, so haloalkanes are derivatives of alkenes. So that means haloalkanes are having more boiling or higher boiling point as compared to parental as compared to parent alkanes. So that means these are the derivatives of alkanes, right? The haloalkanes are the derivatives of alkanes. So that means the parent will be alkane only, right? So these are, that means haloalkanes are having a higher boiling point as compared to the parent. Why? Because the reason is here. Because the parent in parental alkane, that means in normal alkanes, there is no polarity. But already we know in case of haloalkane there will be a CX bond, right? CX bond means partially positive and partially negative. There will be a polarity. But what about normal alkane? There is no polarity. In normal alkane, is there any polarity? Only HH. So that means there will be a no polarity. So that's why parent alkanes, as compared to the parent alkanes, these haloalkanes are having more boiling point because here in the haloalkane there is a polarity because of presence of halogen. But in parental alkane that is not the case. Polarity is not there in case of the normal alkanes. But in case of what haloalkanes there is a polarity, so that's why one we can see a more boiling point, right? One thing, or else one we can say in the haloalkane because of presence of what halogen, so they show a more boiling point, one we can say. See dear student, if we go in depth it will be very interesting, right? So that's why please go through the book, try to read the book. The boiling point of haloalkane increases with the increase in the size of halogen. See, what I said, if they will give more number of halogens, then among which one will be having more boiling point. The one more twist. So the next point, the boiling point increases with increase in the size of halogen, in the size of halogen. So now I will give you one example again. CF, CCl, CBr and CI. Among these, which one will be having a more boiling point means you just see the size. So size order will be like this. Iodine is having more size than the bromine. Bromine is having more size than the chlorine. Chlorine is having more. That means fluorine is the element among the halogen which is having least size. So now iodine is having more size. As the size of halogen increases, the boiling point will also goes on increases, right? And the boiling point is also, see directly, I am giving a hint. Boiling point is directly proportional to size. Sorry, directly proportional. See, you can make this point important point for your main need as well as CET classes also. Boiling point is directly proportional to size. Very important, dear student. This is size, atomic weight, right, and number of halogen. So these are the 3 points. Very important. Boiling point is depend on size, atomic weight. So see, sometime they will give you same number of halogen, then you can use this, right? If they give different halogens, then you go on the size or else on the atomic weight. So this is how one we can touch those very important things, right? So this is all about boiling point. Still some more points are there in the physical property we will be having in the next class, right? Thank you.